Okay. Looks like it's working right now. So here's the warm-up challenge. 0 to 9, only once. So level 1, the two fractions have to be equal to each other. This works because, no, this doesn't work because the 1's repeated. But this one would be good. That one's good because you're not repeating any numbers, and 2/5 is equal to 4/10. So that's level 1. And there's lots of answers for level 1, so you can challenge yourself to see how many you can find. Level 2, still same rules. Using 0 to 9, can't repeat. Level 3, you have to have a set of 3 of them. Equal to each other, and they can't match. And then level 4, Nope, not yet. You got a level 4? Looks good. We got one at level 4.
I just skipped the rest of them at level 4.
Nice. We got different ones at level 4, so there is more than one at level 4. Level 3 is a challenge. Well, you start by trying, right? You gotta. These two probably work at first, and then. Yeah, you're developing some strategies here for what works and what doesn't. I'm just going to pause the video while you're working on this. See how you did. Can someone give, well, we've already got an example of a good level 1, right? 2 over 5, 4 over 10. So the level 1 challenge. Count how many level 1s you got. You did 3? Anybody get more than 3? 8? 50? I don't know. Maybe. So everybody agree there could be lots of answers for level 1. Okay? Now, if we really wanted a challenge, we could say who could find them all, but that might take a very long time and there'd be a lot of them. Okay? Did someone find one for level 2? What'd you find? 28 over 70. So we do a quick check. Are all of the numbers different? 1, 2, 3, 4, 5, 7, 8, and 0. Yes, they're good. Are the fractions equal to each other? Yeah, because you could just take the top one and times by 2 and the bottom one times by 2, and you get them equal. So this is a good example of level 2. Did anybody find more than 1 at level 2? How many did you find?
I'm trying to get that level 4 that's not a half. I think I got a level 4 one.
You think you got a level 4? Well, we'll put up a level 4 one in a second. Okay. Did anyone get a level 3 one? Go in there. What'd you get? 3/4, 9/12 equals 6/8. Awesome. Does any number 1, 2, 3, 4, no 5, 6, no 7, 8, 9? We're good. Okay. Did anybody get more than 1 level 3? And you got a different level 3. So there is more than 1 level 3, because we have people that say, I got 1 level 3, but it's different. Perfect. Would we count it different if someone said, oh, I got a different one. I had 6/8 here, then 9/12, then 3/4. Would you consider that one different, or would that be the same? If you just switched this one and this one, the first and the last one, would you be like, nah, that's really the same, or would you consider it different? I think it might be the same. But you could have arguments. You have a different one? 2/4. 5/10 is equal to 3/6. Very nice.
I have 3/6, 5/10, 47/94.
Oh, but you're on level 4 there.
Oh, yeah.
Okay. I only did 4 levels for today. Okay, so you want to say one of your level 4 ones? What did you have?
I had 3/6,
3/6, 5/10,
47/94.
47/94. Oh! Oh, man. So, that was so close. Okay. Oh, I like this eraser. I think I could actually, if you see me here later in the day, like erasing with my finger, it's because I'm having too much fun. Okay, what did you get for level 4? 2/4. 5/10. 39/78. Let's do a check. We got the number 0, only once, only 1, 2, 3, 4, 5, 7, 8, 9. And I think there's an even bigger challenge on this last one. Take out 0. Can't use 0. You got one without 0? Okay. 3/6. 9/18. And 27/54. 1, 2, 3, 4, 5, 6, 7, 8, 9 uses all the numbers 1 to 9 and works out. Nice. Very nice, very nice, very nice. Okay. So, what we ended off with yesterday in our notes was equivalent numbers. So if you want to take out your notes packages, we were just talking about this, and I realized my clock was off by 5 minutes, so the bell rang. And you could write equivalent numbers with decimals too. Like, would you agree that 0.4 is the same as 0.40? It's the same as 0.400. It'd be kind of annoying to keep adding those zeros at the end. They're not really helpful. But what it lets us do is it lets us also write equivalent fractions, because this means that 4/10 is equal to 40/100 is equal to 400 1,000ths. Did you like that beginning challenge thing? Okay, I'll try to come up with some more challenge things as we go along, different levels. So does everybody have their notes package out? We are on page 8. You got yours out, you're on page 8, you're getting yours. Kyle, do you have your booklet? You're looking for it. Excellent. We're on page 8. And, oh, you've been working ahead. Did we get these ones done? I don't think. You just go, yeah, see, that's what I mean. You worked ahead. That's good. Okay. So, if you know the decimal, what place it's in, then you can change it to a fraction. So if I have 0.53, the 3 is in the hundredths space, so I can write this as 53 over 100. And then the challenge is you have to decide, is this the smallest that fraction can be? Or is there a number you can divide both 100 and 53 by? In this case, you can't. Can you see? You can divide 100 by 2, but you can't divide 53 by 2. You can divide 100 by 5, but you can't divide 53 by 5. You can divide this by 10, and so you go through and sort of have to do a fair bit of mental math to check to see if there's a number that divides both of them. But 53 is what kind of number? It's a prime number, because it's not in your times table, right? 53 is only 1 times 53. So the only way you could reduce this is if the number on the bottom was also 53. Now the second one, though, negative 0.6, that 6 is in the 10th spot. So it would be 6 over 10, and with the negative, we can put the negative in front. We can put the negative with the 6. Are you good with that? Did you know that negative 6 over 10 is the same as negative 6 over 10 is the same as 6 over negative 10? They're all the same thing. But this one I have the negative in front of the fraction. Maybe I'll do it even like right there. So you can so they're written a little bit different, but they all mean the same thing. And 6 over 10, can that one be written smaller? Yeah, you can divide both of them by 2, right? So this is equal to negative 3 over 5. Oh, but did you know that this is not the same as negative 6 over negative 10? Because if you have a negative divided by a negative, then that would be positive. And the last one, we're in our decimal, we get to our thousands, so this is negative 912 over 1,000. And this one can be simplified, but sometimes when you're simplifying things, it gets a little tricky. Okay? Can you see that you could divide both of them by 2? So we'll start with that. We'll make it over 500. 912 divided by 2. 456. Can you divide them by 2 again? Yes. So we do that again. It's equal to, if I divide the bottom by 2, I get 250. If I divide the top by 2, I get 228. Can I divide it by 2 again? Now it's at negative 114 over 125. So even though I didn't figure out, I could have gone directly from the start to the end by dividing by 8. But it's not easy to see. Do you know your 8 times table up to 114? Well, that's good. right? 8 times 114 happens to be 912. But you probably wouldn't be able to see that. So it's okay that we just kept going, oh, I see a 2, take it out. And then I see another 2, take it out. I see another 2, take it out. And I mentioned this already a little bit early on about the repeating decimals. Does anybody remember how to change a repeating decimal to a fraction? Nevaeh? Over 9s. So 0.4 repeated is 4 9ths. 0.27 repeated is over 99. And 0.367 repeated with a negative, this would be negative 367 over 99. Oh, and now you can show you a couple tricks to impress your parents if you want, right? As you can say, we've been doing some mental math in school, right? And one of the mental math things that we're doing is changing fractions to decimals. And then you can say to your parents, so for example, do you know that 1/2 is 0.5? And this is where you make your parents feel good because they you know, they think they're smarter than you, right? So it's so annoying. Parents like, oh, think they're smarter than you. So you start off with like, so you say to your, oh, I'm putting this on the video. I might get in trouble from your parents if they start watching these videos. Okay. So you start off as saying, one of the things that we're doing in class is we're learning how to change fractions to decimals. And then you can say, you know how like 1/2 is 0.5? And then they'll feel like, yeah, I know that, right? And they'll say, yeah, okay? And then here's the one that you're going to impress them with, okay? You are now going to say, okay, ask me 1 over 11. So pick a number, something over 11. 5 over 11. 0.45 repeated. Does anybody know how I did that in my head? How did I get 0.45 repeated? Okay, well, if you had this and I said, can you change this to a fraction, what would it be? 45 over 99. What's the trick for the 11s? Right, so pick another 11. 7/11, let's think Slurpees. Oh, yeah. Okay, what would 7 over 11 be? As a decimal. Can you see the trick? This is a trick. You do not tell your parents a trick. You just make them think that you're a genius. That's the key. You times it by 9, which would make it 63 over 99. And it's 0.63 repeated. Yeah, you do 33 too, yes. Right? Oh, it's like, and then your parents are like, whoa. And then you try one on them, yeah. So can you do one? What's like 12 over 33? And they'll be like,
Yeah.
Well, we'll see. You try. Yes, you might catch them off guard. So. Super cool. Well, I don't know if it's super cool. Sometimes, okay, just warning you. It might not be, it might not.
It's not super cool, it's super duper.
Oh, super. Well, you know, I'm just going to warn you. You know, if you're out with a bunch of friends going to a movie and you're like, hey, you want to see some math tricks? It's not necessarily the right time, right place. It is super cool, but I have to warn you, you don't necessarily want to bring out your math tricks all over the place. And people start getting, they're like, okay, yeah, Our movie night got canceled, they tell you next week. Okay. So, try 3 of them on your own. Or 4. Yeah, there's 3 of them there. And then there's 4 more where you have to try to convert them to a decimal. I'll give you the answers in a couple of minutes.
This is what our first test is all going to be on?
Our first quiz is going to be on the number families and changing from fractions to decimals. I looked at it today. We've got some fraction stuff on there. Pretty soon. I was looking at our notes. We got a couple more lessons that I want to get through. And then I'll tell you when the quiz is. I want to do some order of operations. Question, yes. Yeah. All right, let's check these first 3. How did you do? Did you get 24 over 99? Did you notice that this one could be reduced to 8 over 33? Sure. That's, no, you missed it. Do you know why you missed it? Because you felt so good about getting that one. You're like, I got this one too, and you just like wanted to quickly write down all of them. Okay? You just got the 9s there. Because I'm pretty sure all of you missed the last one too. That you can reduce the last one. You can divide all of them by 9. And it can make it over 111. Oh, and 117 divided by 9 is not too much. Is 13. Now, all math out there. There is a trick. There is a trick to tell if something can be divided by 3 or can be divided by 9 really easily. Tell me 8 numbers. Just tell me digits.
8, 9, 4, 3, 2, 5.
Okay. What are we at? I need one more, right?
6.
Okay. You cannot divide this by 9. But if I put a 1 here, you could. Whoa. If the trick for finding out if something can divide by 3 or by 9 is, so I heard someone say it, you add up the digits. So we got, and I have to check if my adding was right. 7 plus 5 is 12, plus 8 is 20, plus 9 is 29, plus 4 is 33, 36, 38, 44. At this point, we were at 44. If I added the 1, we would add up to 45. If the numbers that you add up to can divide by 3 or can divide by 9, then the whole number can divide by 3 or divide by 9. Let's do a double check. I'll pull up my calculator. It might take 5 minutes. We can take this, and so what I did in this one is, for sure I know that 9 plus 9 plus 9, which is 27, divides by 9. But 1 plus 1 plus 7 adds up to 9, and so I knew that I could divide 117 by 9. All right, I tried to open up my calculator. It's not working. Sorry. That's your cool dividing by 9. Do you know the trick for dividing by 11? I shouldn't get off topic. Keep going off. This is interesting enough? Okay. So the following number. You can divide that by 11. Check it. Can someone check it? Is 8,091,464 divided by 11 work out nicely?
32.
Yes? Did you try it?
I did the last one, which was,
It works if you divide by 9?
yeah.
Yes.
Okay, now we're doing
8091644. Divide by 11. It works? What happens if I take off both the 4s? Does it still divide by 11?
I don't know.
Yes, it does. What is the trick for dividing by 11? It doesn't?
Oh, I put 906.
Yeah, you can't write. If you write the number in wrong, it doesn't work. The trick for dividing by 11 is take the first number, subtract, then add, then subtract, then add. 8 minus 0 is 8, plus 9 is 17, minus 1 is 16, plus 6 is 22. And if the number you get divides by 11, then the whole number divides by 11.
You subtracted first?
You add, subtract, add, subtract, add, subtract. So when I add 44 onto the end of this, it means I subtract 4, add 4. Doesn't make the difference on the end.
Wow.
Crazy. Do you know what's even harder? Is like, this is the job of higher level mathematics. You see cool patterns like this, and then the higher level mathematics people say, well, why does that work? And it's like, oh, why does that work? That's a harder thing. Seeing that it works is cool,
It doesn't.
but figuring out why it works is a challenge. I'd have to think about it, probably for like, what you have to like examine how 11s work, how multiplying by 11s work, play around with it, and then you'll see why. Oh, no, it's fun times. Okay, change these ones to decimals. Did you get 0.5 repeated? Did you get 0.52 repeated? Did you get, 0.36 repeated on that one? And did you get 0.39 repeated on that one? Because you times by 3, right? But you don't tell your parents the trick. You just impress them. That is the key. Right? And you can even maybe you do this with your dad and you say, well, if he doesn't get it, you just say, well, if you buy me an ice cream, I won't tell Mom you didn't get it. Something like that. Oh, yeah. All right, here we go. Opposite numbers. In mathematics, we have opposites, so we would say -1 and +1 are opposites. And you can have it with fractions. 1 3/4 is opposite of -1 3/4. That's not too crazy. Opposite numbers aren't too bad. What's the opposite of 5? Oh, you guys are amazing. Right? Oh, whatever. I could give you one that you couldn't get. You think so? Or you think I couldn't? Yeah, I could just make the number so long you couldn't remember, right? That would be the trick. Oh, yeah? Could you get 0.5673215438854? What's the opposite? You'd be like, The key is you could probably say it fast enough back, and I don't even remember the numbers that I said. Oh.
Negative the number you said.
Quickly change these to fractions, but I want them in lowest terms.
Here?
Yeah, right there. Change. Yeah, you did the opposite, right? Yeah. See, I'm keeping you on track, on your toes. So Kale, while we're doing our notes, then I'd like the phone either in your bag or away, okay? And headphones off because Well, you can listen to music and stuff while we're doing work, but not while we're doing the notes. Does that make sense? And I know that sometimes, like you have earbuds or things like that. Yeah, same thing. Sometimes you have earbuds and you can say they're off, but I can't tell if they're in your ears, if they're off or on, right? So just this is this thing about out of respect, it's more respectful that you would have them off than while we're doing the lesson part. And if you want to put them back on or in when we're doing some homework questions, then that would be fine. But you'll see that I tend to do this more often. Instead of giving you like a chunk of time for homework, and I'll do that sometimes, in the notes every once in a while I'll put questions for you to do. So you're kind of doing homework a little bit all the time, and then that sometimes means we don't have homework to take home. Did you get 1/10 for this one? Is it in lowest terms? All right. Did you get 32 out of 100 for this one? Is it in lowest terms? No. What?
8 over 25.
Yeah, you might first divide it by 2 to get 16 over 15, then divide by 2 again to get 8 over 25. That's the one in lowest. And the reason that there's kind of like, I think there's 2 reasons that they always want to say things in lowest terms, right? Why is it better to write it as 8 out of 25 than 32 out of 100? Well, some might argue sometimes it's better in one than the other. If I want to change it to a decimal, can you see that 32 out of 100 is way better than 8 out of 25? I can change it to a decimal way faster, 32 out of 100, right? Just wrote my English test, I got 32 out of 100. What's the decimal? What's the percentage? Ooh, I shouldn't have told you I got that on my English test. But if I got 8 out of 25, it's harder to figure that out. But when we want to write as a fraction, the reason they want it in lowest terms is because if everybody puts it in lowest terms, then you can check, did we get the same answer? Because you're talking to a friend, they're like, I got 16 out of 15. Oh, I got 8 out of 25. We got different answers. We should both redo it. No, we want to make sure you have it in lowest terms so that you can check the answer that way. Percentages are a big part of school, right? Because you're always like, what percent do you have in that class? How did that percent get calculated? What percent did you get on a test or a quiz? How do you change decimals and fractions to percentages? Those are very important. You use percentages when you go shopping. You're like, ooh, I like this store, and right now it's 20% off. Okay? Maybe the whole store is 20% off, but they have the prices there. So you might want to do the mental math to say, if it was $10, 20% off means it's now $8. How do we figure that out? How do we do that mental math? Because I guarantee you, in the future, sometime you're going to go into a store that's going to advertise something is a percentage off. Okay? My favorite, when I'd go shopping, my favorite sale that I ran into was 70% off the lowest price. So it was already 100% off. Yeah. Best deal I've ever got on an item was 95% off. It was pretty impressive.
So you pay less than what you pay for tax?
No, wait a minute. It wasn't 95. It was 97.5% off.
Wow.
Oh. Because they made a mistake in the store. A little bit. So there was a $200 item. There was a $200 item that was underneath a table, and on the table it said everything $5. So I went to the table, I'm like, ooh, this looks cool, and I picked it up, and it was on sale, regular $200. It was already on a good sale for $91 or something crazy. So that's still over 50% off. But I was like, I don't need this, really. I don't need to pay $91. So I was like, I was holding it, and there was a little note. There was a little note on there. It was a big Lego set, a $200 Lego set. Okay, and there was a note on there that it said it may be missing a few pieces. So I'm like, well, I don't really want it if it's missing a few pieces either. But I was holding it, and the manager comes by and says, if it's missing a few pieces, you know, you can call Lego and they'll send them out for you. And I jokingly said, because it was on the $5 table, well, I would pay $5 for it. And the manager said, okay. Yeah, I was like, oh. So I was all super excited.
Yeah, like I did fired.
So if it was regular $200 and I paid $5, that is 97.5% off. That's a really good deal. Okay. Anyways, a percentage is a number over 100. So 62% is 62 over 100, which is 0.62. And whenever you hear percentages, right, if you see something like 20% of $10, if you want to figure out what 20% of $10 is, you can change the 20% to 0.2 and multiply it by $10 and find out that 20% of $10 is $2. And if something says it's 20% off, well, if 20% is $2, 20% off means you take $2 off, and then you would only pay $8. Okay? We deal with percentages every time you buy something, except for milk. Milk's okay. Right? Groceries are okay. Why am I saying groceries are okay, milk's okay, but everything else you buy deals with percentages? You pay taxes. You don't pay taxes on groceries. Yeah, so you buy milk, it says $4.65. Woo! Buy milk, $4.65. But some things aren't considered groceries, like that big bag of Doritos. It looks so tasty. They're like, no, you are not having just Doritos for supper. As much as you would like that, you have to pay taxes on that. So we can change percentages to decimals, right? If something is 20, does it make sense? If something is 20% off, that you pay 80% of the price? So if I did 80% of $10, I'd get $8. So those are things that you can figure out with percentages. And the thing that happens all the time is you pay taxes. How much are taxes in Manitoba right now? 12%. You pay 5% GST and 7% PST, 12%. So you're like, yay, Dollarama, it's only $1. Oh, no, it's $1.12. You better round down to $1.10. You should ask them next time, can I pay for this chocolate bar in 2-cent increments?
We don't have 2 cents.
Right, so they'd have to round down. So if you bought a chocolate bar for $1.12 and said, can I pay for it 56 times at 2 cents? And if they agree, the first 2 cents would cost you nothing. The next 2 cents would cost you nothing. And then you could get everything for free. But I'm pretty sure they don't allow that. You can ask. The cashier will look at you like you're crazy. Because I am a little crazy? Yeah, I know. Yeah, just say, can I just have the free one? Okay, here's some for you to try. How to do these ones? So 7% is 7 out of 100, which as a decimal would be 0.07. So B and C. 13.5% would be 13.5 out of 100. And this feels a little bit weird to have a decimal in a fraction, but then when you change this to a decimal, 0.135. So 13.5% is really 135 out of 1,000. Yeah, we got another one of the decimal. Would you agree that 5 1/4 is 5.25 out of 100? And the 5 would be in the hundredth spot, 0.0525. Sneaky. 112 out of 100. And this one is the most important one of all of these. Because that is, hey, if you have to pay an additional 12% on anything, you pay, what are we going to buy? We should buy something theoretically that makes us happy. What are we buying? A chocolate bar? I like chocolate. Chocolate, a pickle? No. So if the chocolate bar, I'm going to imagine here, if we're getting a chocolate bar, I'm going high end. It's like one of those, the big Toblerone. That's what I'm getting. How much are those big Toblerones? They are not cheap. They're like $15 chocolate bar. How much are we going to pay? The way that you can add 12% really quickly is to multiply by 1.12. The reason you multiply by 1.12 is you multiply by 1 because you still have to pay the $15, but you have to add 12%. And adding 12% adds 0.12. If you multiply 15 times by 1.12, what do you get? Oh, I just did this quickly. I don't even know if that's correct. Is that right? Someone have a calculator? I just mental mathed it. $1.80 of taxes? Does that sound right?
None of you have your calculators out?
Yeah, 1680. But oh, I've had that happen too. My best ever deals at a grocery store once. I bought some cold cuts, and every time I bought cold cuts, they gave me 30 cents off something else. It was such a good deal. Yeah, I was like, this is such a good deal. Because the price on the package was regular. Here we are. This is me, like on the coupe. The price was regular $1.60. Okay? It was on half price for 80 cents. And then had a sticker on it that said $1 off.
So you're only getting 20 cents, not 30.
Okay, 20 cents. Something like that. I don't remember the numbers exactly. But I was like, if I buy 50 of these, if I buy all of them, I don't think they had 50. They might have had only 10. But let's make a better story. If I buy 50 of them, they're like, what is this guy doing? He's got 50 packages of cold cuts. He's never going to be able to eat that much. But every time I buy one, I save 20 cents. 50 of them would mean I get $10 off of something else. That's a good deal. You may.
What, everybody, come get your cool cuts.
No, I wanted to
This
do.
is a great deal.
So I like. See, I think I like getting good deals, and I like doing the mental math. And if they have deals like that, you're like, ooh, this doesn't happen very often that the store pays you to take something home. But every once in a while, they make mistakes. Yeah.
It's like this guy that accidentally puts in the gun a total markdown of like everything is 25 cents, not 25% off.
Oh.
And so as everybody's just going chaotic, the one girl comes up, she's like, what did you do? And he's trying to explain himself. She's like, that means everything
TVs for 25 cents. Quickly get them before they notice.
Way too funny. You gotta
Uh,
preview that.
yeah. Those are good things. Every once in a while, you get a good deal, like my $200 Lego set for $5.
Without popping tags.
And I built it. It was hard. It was, oh.
Is there a piece missing?
Yeah, and I phoned Lego and they sent them out for free, just like Tiz said. It worked out perfect.
How many pieces are missing?
7.
That's too much.
And the set had 2,000 pieces.
Oh my goodness.
I know.
Kind of aggravating that.
That would take a whole month.
Yeah, 2,000. And the instruction books was like 200 pages to do it. And on page 100 is when I realized I made a mistake on page 2. You know, it's so bad. Yeah, it was like, oh, it was sad. Because it was like this crazy big truck thing. Oh, yeah, I still have it. It's like, I should take it apart and build it again sometime. Okay. Just the rest of the year, just build Lego. Okay. Could do that. I have enough Lego sets. We could do that for the rest of the year. 2 rational numbers between 1/4 and 1/2. So what I've done here is I made a number line going from 0 to 1. Normally when you make a number line, don't you normally feel like you do this? 1, 2, 3. Is this probably your most common number line you've ever seen? Okay. Now, with a number line, you decide what you want to break it up to, and you decide what section you're going to look at. So right now, can you see in the number line that we're looking at, I'm just looking between 0 and 1, is the number line I gave you on your notes. And then I decided to break up between 0 and 1, break it up into 10 equal sections. Do the decimals make sense for you? That if I broke that up into 10 equal sections, I'd have 0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 0.9 and then 1. And what this lets us do is we can put things on the number line, because we can change fractions to decimals. 1/4 is 0.25. 1/2 is 0.5. So we go on here and we go, well, where's 0.25? Ooh, 0.25 would be between 0.2 and 0.3. And 0.5, well, that works out perfectly right here. So if it asks for 2 rational numbers, so again, now this is the language that we started this unit with. Remember the grocery store? Rational numbers includes all fractions, all decimals that repeat, all decimals that end. So the question could be, well, if you wrote the answer to this, right, 2 rational numbers between 1/4 and 1/2, if you wrote that as a decimal, can you see that the ones that show up are 0.3 and 0.4? Yeah, that would be easy enough. You could write them as fractions. Okay, do you want a challenge? Because if that was easy for you, you want a challenge? Can you tell me an irrational number between 0.25 and 0.5? Hold on, yeah, see, that's a bit of a challenge. Pi is 3.14, is not in between there. Ooh. Pi is irrational, but it's not between. It's 3.14. We need it between 0.25 and 0.5.
Well, it could be a square root of a number and
Yeah, you just,
I don't know.
1.5 square root of 1.5. No, that's 1 point something. Square root of 0 point. You're on to something. What are you going to put in there? Try it. 0.6 if you're right. Well, we'll see if 0.6 when you square root it, is it in between 0.25 and 0.5? No, it's not. It's like 0.8 is an answer. Oh, so close. Ooh, that one's going to be close. Is? What is the square root of 0.1? 0.3146 dot dot dot? Well, so there's an irrational number. The square root of 0.1 is an irrational number between. But you had to use your calculator to figure it out. No, I didn't say you couldn't. Okay, so in your notes, bell's going to ring soon. I'd like you to try the next two to the bottom of the page if you want to. We can do there's 3 more on page 13. You can check your numbers. Okay, I will take that and that's all right. I will take out my trusty ruler scissor and cut it and get it back to you. Thanks, Raylyn. There's that back. Oh, I will stop our video. It's going a long time here.